All right, we're on lesson 1.6. It's our second lesson from chapters 1 and 2. This one is all about solving compound and absolute value inequalities. So we just looked at absolute value expressions and equations in our last video. Now we're going to look at how that applies to inequalities. We're also going to graph inequalities on these number lines. Now these number lines, you'll notice, don't have any numbers on them. You will mark them as we go. So a couple key terms here. Compound inequality is just two inequalities that are joined by the word and or by the word or. So inequalities using and or. Now a couple things I want you to note about and or is, let's say I was in a room and I wanted all of the people who were born in summer and were taller than 6 feet. Okay, that's going to be a lot less people than if I said taller than 6 feet or born in summer, right? This would include everybody. Only one of those things has to be true. Everybody's allowed there. This word and would say both things has to be true. So for and, I want you to write both, kind of make a note that this one means both things. This one just means one of those things has to be true. Okay, so the overall term is called compound inequality. They get a little more specific. Intersection is what it's called when you use and. It's the graph, like on this number line, the graph of a compound inequality using and. A union is graph of a compound inequality using or. So intersection, again, these intersect. It only works for both. Union, or. Either or is true. Okay, so let's look at a few actual compound inequalities. We're going to use an and compound inequality. So remember, and comes from up here, intersection. So this graph is going to be what's called an intersection. Now right here, we technically have two inequalities. Even though it looks like just one big one there, if I were to block out this piece, here's one where it says 10 is less than or equal to 3y minus 2, which is actually the same as saying 3y minus 2 is greater than or equal to 10. Let's flip it over here. At the same time as that inequality is happening, we have this inequality happening. 3y minus 2 is less than or equal to 19. So there's technically two inequalities happening right here. We know that because there's two symbols. Now luckily, when it's written all together as kind of one piece, it makes solving it really easy because you just do the same thing to all three sides. Normally when we solve equations, we just, balance it by doing the same on both sides. Well, now there's three sides, we just do the same to all three. So if we're trying to get y alone, first we would add 2 to all three sides, and this 10 would change to a 12. 3y minus 2 becomes just 3y. 19 becomes 21. All these inequality symbols stay as less than or equal to, so 12 is less than or equal to 3y, which is less than or equal to 21. Now to get y alone, divide everything by 3. 4 is less than or equal to y, which is less than or equal to 7. At that point then, we're now thinking, okay, even though it's written all as one inequality, if we wanted to, we could split it into two different inequalities. Y is greater than or equal to 4, right here, and at the same time, y has to be less than or equal to 7. Now I know that these don't have numbers on them, so we are just going to make the tick marks as needed. 4 down here to our left side, that's the lower number. 7 up here, that's our higher number. So you can, mark whatever numbers you want, but those are the only ones we really need. Now we just know that 4 has to be greater, or y has to be greater than or equal to 4. So we know that there'd be a filled in circle at 4 going all the way up. We know that it has to be less than or equal to 7. Filled in circle at 7 going all the way down. Now because it says and, we want only the area that it's true, where both of these work out. So this line starts at 7, covers everything below it, and into infinity. This line starts at 4, goes everything above it up to positive infinity. So the only area where both of them are true, what you would draw right on the line, is a filled in circle at 4 because they both include 4. That's what this little line underneath means. It includes it. So we include 4, we include 7, but that's it. Those are the endpoints, and it's everything in between. So your line should look, or your graph should look something like this. It's the purple line here. It's filled in at 4, filled in at 7, everything in between. Notice it's not anything less than 4, it's not anything greater than 7. Even though this red line had things bigger than 7, this green line had things less than 4, we only wanted things where both were true because it said and. And means both have to be true, so we use this purple line on our number line here to show that this is the area we want. Let's try an OR compound inequality. This one separates out our inequalities into two statements actually separated by the word OR. So we can't really write them all as one long inequality like we did with our last one. So for this OR one, we'll solve each of them separately. So we start with this x plus 3 is less than or just less than, there's no equal to, just less than 2. So to solve it, subtract 3 from both sides, and we would end up with x is less than negative 1. That's it. So that's going to be one of our inequalities then. For the next one over here, we have negative x is less than or equal to negative 4. To get this x to be positive, we're always solving for a positive x. Multiply both sides by negative 1, or if it makes more sense to you, divide both sides by negative 1. It's going to do the same thing. It just changes the signs, and it becomes x is greater than or equal to 4, positive 4. Now, one thing you should note, for any inequality, when we have less than or equal to's, if we're multiplying or dividing by a negative, this just says multiply, but dividing it too, multiply or divide by negative, you must flip this inequality symbol. So it was less than or equal to, now it's greater than or equal to. Okay, the or equal to stays. If it was just less than, it would become greater than with no or equal to, but that or equal to will always stay there. So now, these two blue ones, these are our, I'm going to get rid of these boxes. These are the two inequalities we're working with. So we'll make our tick marks here. We've got a negative 1. We've got a positive 4. Now we're saying or this one or this one, which means it's all of the area where either of them are true. We're not looking for just where they cross each other, where they intersect. That's why the and is called an intersection. It's where they intersect. This is the union. This is everywhere that counts. So this one, less than 1, would be an open circle at 1 and everything lower. This one, greater than or equal to 4, would be a filled in circle at 4 and everything above it, greater than or equal to. Now for an or, because it's a union, we can literally just place those right on there. And we'd say all of this stuff is true. So anywhere here and lower, anywhere here and above, that would fit these inequalities. Okay, these ones would all hit this one, these would all hit this one, and because it says or, it's just saying either this is true or this is true. We want all of the x values that count for either of those. Okay, so that would be how to do an or compound inequality. Notice there can be two totally separate lines. That's okay. Now we're going to move on to an absolute value inequality. So before we talked about absolute values with equations with an equal sign. This is going to change it up a little bit. The sign right here is going to be an inequality. So our first one, we're doing a less than. So the absolute value of a is less than 4. Now a note that I want here, just like with equations, you're going to get the absolute value piece all alone, and then you're going to do two and cases. We do and cases with less than. So if you want to make a note of that, and goes with less than. Okay, or we'll go with greater than, and goes with less than. So absolute value of a is less than 4. So we make two cases, one regular, or positive, we should say, regular, just keep everything positive. So A is less than 4, just like what it said here before. The other case is negative. So everything in the absolute value stays the same, so it's just A. This sign flips, because we made it negative, and 4 becomes negative. So again, the note for that is, for the negative case, you must flip this symbol. Now remember, we're doing an AND case. So this is only where both of them are true. So we make our tick marks for each of these inequalities, and then find the spot where both work together, where it makes an intersection. So using this positive one, we want A is less than positive 4. Not less than or equal to, so we have to do an open circle. Less than that, so everything below this one. Okay, for our negative one, we had A is greater than, not greater than or equal to, just greater than negative 4. Since it's not or equal, it's an open circle. Greater than means everything above it. Okay, this is an AND case, so we want everywhere where they cross each other, which means this one doesn't include 4, but includes everything less than it. This one doesn't include negative 4, but includes everything above it. So the only areas where both are true would be an open circle here, and everywhere in between. So the only A values that would be true for this inequality would be any value not including negative 4, not including 4, but all of the ones in between there. Now let's see if that makes sense. Let's pick a number right here, negative 1. If we plugged in negative 1, absolute value of negative 1 is 1. Is 1 less than 4? Yes, it is. That makes sense. How about what if we did like a positive 3? Okay, plug positive 3 right here. Absolute value of positive 3 is positive 3. Is 3 less than 4? Yes, it is. Again, this is the only area that makes sense. If we tried one that was out here, negative 6, plug that in here, absolute value of negative 6 is positive 6. Is positive 6 less than 4? No, it's not. That's why this one is not included in our area. It's just this stuff in between negative 4 and positive 4. So that would be an less than absolute value inequality. We have a couple more here. We're going to do a greater than absolute value inequality. So it's going to be kind of the same steps. We get the absolute value alone, but then we're going to do two OR cases. So just like before, in fact, everything is the same except this was less than, now it's greater than. So this one stays the same. It's our positive version. This one is our negative version, so the sign has to flip there. We have a negative 4. We have a positive 4. For the positive one, it's A is greater than all of that. So open circle, everything above. For the negative version, less than that. And everything below. Since it's OR, we want both to be true. So we can just move these right on to our line. And it says all of these work. So again, same thing. If we want, we could test it out. Let's pick a number like 1. This one should not work out because it's not in our line. If we plugged in 1 right here, absolute value of 1 is 1. Is 1 greater than 4? No, it's not. That's why this one doesn't work. Let's plug in something higher, positive 6. Absolute value of 6 is 6. Is 6 greater than 4? Yes, it is. That's why it's in the area that works. Same thing with anything that's like further negative, like a negative 8. Plug that in here. Negative 8 becomes a positive 8 with absolute value. 8 is greater than 4, so it would work. Okay, so all of these values, anything less than negative 4, anything bigger than positive 4, those are all the spots that would work. All right, for our last example, we're going to solve a multi-step absolute value inequality. So this one's going to have a few steps to solve it, but in the end it should be pretty similar to what we were doing. So anytime that you are solving absolute value inequality, you have to get the absolute value piece alone, just like we did with the equations. In this case, it is alone. It's just the absolute value piece is greater than or equal to 6. Okay? Now that we're at that point where this is all alone, because it is a greater than or equal to, just like this one was greater than or equal to, this is going to be an OR case. This true or this true. So we want everything that works. So this is a union. Okay, if this was a less than symbol, that would be an AND case, and it's only where both are true. But because this is greater than, it's going to be an OR. So if we do a positive version, take all of this, just keep it regular. We do a negative version. This stays the same, 3x minus 12. This symbol flips, less than or equal to. 6 becomes negative 6. So that just flipped. We're going to solve these two and graph those as an OR case. So both will fit, both work. Add 12 to both sides gives us 3x is greater than or equal to 18. Divide by 3 from both sides. X is greater than or equal to 6. Same thing over here. Add 12 to both sides. 3x is less than or equal to 6. Divide by 3 from both sides. X is less than or equal to 2. So again, we make our marks. Positive 2, positive 6. For this case, for our positive case, x is greater than or equal to 6. So it would be filled in at 6, and it's everything above that that fits. For this negative case, x can be equal to, so a filled in circle at 2, but it's everything less than that that works. Because it's an OR case, we want all the places where either one can be true. So all of these ones work, all of these ones work. Okay. Again, if you want, we can kind of test it out. Let's pick 4. 4 is right in between here. So if we plug in 4, 3 times 4 is 12, minus 12 is 0, absolute value of 0 is 0. Is 0 greater than or equal to 6? Nope. That's why this one doesn't work. If we wanted to pick something bigger than 6 to check it and make sure it works, let's try 10. 3 times 10 is 30. Minus 12 is going to be 18. Is 18 greater than or equal to 6? Yes. That's why all of this area works. Let's do something less than 2. Let's do 0. 3 times 0 is 0. Minus 12 is negative 12. Absolute value of negative 12 is 12. Is 12 greater than or equal to 6? Yes. That's why 0 is in the area that works. So that's a nice way to kind of check these and make sure this works. So that's all you need to know right now about graphing inequalities.